In this tutorial, we're going to look at graphing equations and finding the slope and intercepts from a graph. Graphs are very important in physics because they show us the relationship between two variables. So we're going to be doing quite a bit of graphing, and we need to be able to interpret graphs in physics. So to remind you kind of some terminology, the vertical axis of a graph is referred to as the y-axis. The horizontal axis is referred to as the x-axis. Now we're going to graph all kinds of different variables, so we want to always call them y and x. For instance, in our first graph that we made, the x-axis was time and the y-axis was position. The term y-intercept is simply the y-value of the point where your graph crosses the y-axis, and your x-intercept is the x-value of the point where the graph crosses the x-axis. So to give you an example, if I have a graph that looks like this point right here will be referred to as the y-intercept. This point will be referred to as the x-intercept. And we'll look at some more concrete examples in just a second. Because units are very important to us in physics, we need to know how to find the unit of an intercept. The unit for the y-intercept is simply the unit that is graphed on the y-axis. The unit for the x-intercept is the unit that's graphed on the x-axis. So let's look at a quick example. So here we have a graph that's got three different objects graphed on it. If you look at the y-axis, you see that it says magnetic field, and the unit is capital T, which stands for Tesla. And if you look at the x-axis, we've graphed x over there, and the unit there is m, which stands for meters. Things we'll learn about throughout the year. What we're going to do here is we're going to find the y-intercept for each of those three graphs. So let's look at A first. Find the point where A crosses the y-axis, which is right there, and then find that y value. So the y value there is 0, so you simply write 0. The unit that you put behind there is the same as the unit for what is graphed on the y-axis, in this case a capital T. And so our y-intercept would be 0t, or 0 Tesla. For graph B, my y-intercept is up there. Its value is 40, and same unit, capital T. Looking at graph C, there's the y-intercept, which is negative 40, and it would still have a unit of capital T, Tesla. Now let's find the x-intercept for each graph. The x-intercept for graph A would be right there again. It crosses the y-axis at the same point it crosses the x-axis, and so its value would be 0. The x value right there is 0. The unit is whatever we graph on the x-axis, which in this case is lowercase m, or meters. So I put a meter behind that 0. To do graph B, find the point where it crosses the x-axis, find its value. You may have to do some interpolation, so directly between 4 and 6 would be 5, and the unit would still be lowercase m for meters. Graph C, on the other hand, never crosses the x-axis. It's parallel to the x-axis, and it's never going to cross it. So you would simply say that there's no x-intercept. Next thing we're going to talk about is slope. The purpose of finding the slope of a graph is the fact that it shows us how the y variable changes when the x variable changes. The steeper the slope is, the more change in the y variable for every incremental change in the x variable. The key thing here is change. Change is very important to physics. Things like velocity represent changes. And so typically the slope is going to be the most important thing about a graph in physics. We'll be finding slope quite a bit. And if you're ever looking at a graph and you're being asked a question about it, chances are the slope is the thing that you're going to focus on. The definition of slope is the change in the y variable over the change in the x variable. Now that's kind of a long thing to write out, so typically we'll shorten it to something like this. Now you may be familiar with that triangle symbol. The triangle symbol is the Greek letter delta, which represents change in. So the way that you would read the purple middle part there is change in y over change in x. We can calculate the slope from a graph by using the y2 minus y1 over x2 minus x1 equation. So the definition of change in math is final value minus initial value. So you just subtract one y value from the other, and that gives you the top part. Subtract one x value from the other, and that gives you the bottom part. Now, a word of caution. Do not simply count up and over. The graphs that we'll typically deal with in physics will not have the same scale on the x and y axis. So you can't just use the lines on the graph and count them. You actually have to figure out what your coordinates are and use that slope equation. The unit for slope is the unit for the y-axis over the unit for the x-axis. So since slope is change in y over change in x, the unit for slope would be your y unit over your x unit. So let's look at an example. I've got the same graph with the same three objects plotted on it, and what we're going to do is we're going to find the slope of each of those objects. So starting out with point A, the first thing I'm going to do is write down the formula that I'm going to use to calculate the slope, the y2 minus y1 over x2 minus x1. Then I'm going to pick 2 points from the graph that are actually on that line. It doesn't have to be the same points as somebody else picks. What I would recommend that you do is pick points where the line actually crosses the grid, because then you can actually precisely tell what the value for the x and y coordinates are. So for this graph, I would pick that point there at the bottom and that point right there in the middle, because it crosses the grid lines at exactly those 2 points. So getting ready to do my substitution, the coordinate for that point is 5, 20. X value is 5, y value is 20. So I'm going to put in y2 as being 20, x2 as being 5. And then the coordinates for the second point are 0, 0. So that's real nice. So now I just got to do some arithmetic. 20 minus 0 is 20. 5 minus 0 is 5. And 20 over 5 is 4. Now I'm not done yet. I still need to figure out what the unit is. The y unit is Tesla, capital T, and then over the x unit, which is meters. So my complete answer for the slope would be 4 Tesla per meter. Finding the slope of line B, do the same thing. Start out by writing our formula. Pick 2 points. I'm going to pick the first and last point for this example. Figure out what the coordinates are, and substitute. So in this case, my y2 is negative 40, my y1 is 40, x2 is 10, x1 is 0. Now all I have to do is do the arithmetic. Now be careful, negative 40 minus 40 is not 0, it's negative 80. 10 minus 0 is 10, and so negative 80 over 10 would be negative 8. And don't forget the unit, Tesla over meter. Finding the slope of point C, do the same thing. Find 2 points. My blue point down there at the end is the same as it was in the previous example. Substitute. Y's over x's. Now negative 40 minus negative 40 is 0. So you end up with 0 over 10, which is 0. Whenever you see a horizontal line, that's going to be something with a slope of 0. A line sloping up has a positive slope. A line sloping down has a negative slope. Things that we need to remember. Another thing that we need to remember is that the steeper the line is, the greater its slope. So if you just kind of compare B with A, B is much steeper than A is, and so B's slope would be greater. If you compare that with what we found for the A slope, we got 4. B slope, we got negative 8. That should kind of make sense to you. You should now be completing the graphing practice assignment, which has 2 more examples for you to do on your own.